So in our last little mini lecture, we introduced the idea of timekeeping. And so in the timekeeping discussion, then we said that, why is the sun not actually highest in the sky, or even why is it not overhead, but why is it not highest in the sky at noon? Okay. And so that didn't seem to make sense based on our definition of noon here. And the reason is, first of all, keeping track of the difference in local mean time and local solar time. So that gives you a few minutes difference. But there's one other thing, and that is the government says what time it is. And they sometimes have other ideas as to setting time besides what the sky is doing. Okay. We'll get back to that in just a moment. If you were to go out and look at the sky and every day look at exactly the same time of day in the same direction where the sun is, it would be going north and south over the course of the year, and sometimes early and sometimes late in the sky. So this is a composite of photographs an amateur astronomer took about 20 or 30 years ago, doing that every day, or about once a week, going out and looking at the sun and sandwiching all the pictures together, and that shape we call the analemma. Okay. And so that's kind of a mapping of the north and south nature of the sun, and the east and west, early and late. Well, there's another issue, and that is that every city and town would be different because the sun rises earlier in the East Coast than it does in the central part of the U.S. For example, in Atlanta over here, the sun reaches noon before it does in Mississippi and before it does in DFW. And so that's why the clock is an hour and ahead there. Los Angeles, it happens later, so the clocks here are 2 hours behind the clocks here, where we are. Okay, but wait a minute. Jackson, Mississippi over here, and Fort Worth, that's earlier. So the sun should be higher in the sky there before it is here, and it is about half an hour. In fact, in Dallas, it's east of Fort Worth, and so the sun is highest in the sky about 2 minutes earlier in Dallas than it is in Fort Worth. And so now in the old days, they actually kept track of time. Every place was different. And so if you were on a train and you were going across country, the train station would have a bank of clocks, and each clock would be a minute or two different from the one next to it, and that'd give you the time everywhere that the train stops. So the time was different everywhere. Every time the train stopped, the time was different. And so what happened was they decided that's a very inefficient way to run a railroad. And so the railroads decided that all the trains in one part of the country would run according to the clock in one train station. And all the trains in a different part of the country run according to the clock in a different train station, and so forth. Eventually, all the cities and towns converted their clocks to what the trains were doing. And that became the origin of the time zones. Central time zone, where we live, is set for the local mean time at 90 degrees west longitude. That's roughly New Orleans. So when the sun's highest in the sky in New Orleans, everybody in this time zone sets their clock to noon. We're 97 degrees west, so that's 28 minutes, 7 degrees more. So each degree is 4 minutes. So the sun actually is going to be highest in the sky here about half an hour after it is New Orleans. So the clock is going to read closer to 12:30 than it will noon. Okay. If you're in Nashville, Tennessee over here, that's east, and so the sun is actually going to be highest in the sky about 11:40 something instead of at noon. Okay. So that's how all this sort of thing shifts, and that also means it sets earlier. Okay. So that's the shift, and so that would seem to make sense. So to convert, then what you have to do is you got to convert here. So for Dallas, it's 27 minutes different. For Fort Worth, 29 minutes different. So local mean time is whatever the clock is reading minus 28 minutes. So your star charts you use to look at the sky use local mean time. So you have to figure out, well, what time do I want to go look? Well, take what the clock reads and subtract about 28 minutes, or about half an hour. Okay, so that's one way of thinking about it. If you want to be kind of gross about it, not super accurate, just subtract half an hour from what the clock reads, and that's the time according to the sky. Or figure out what time it is according to the sky, and then add half an hour. Well, now Congress gets involved, and that always messes things up. So Congress gets involved and says, "Oh, wait, okay." And the idea actually goes even further back. It goes to Ben Franklin, who had this idea. Hey, if you get up at the same time every day, then you're wasting daylight in the summertime. So you ought to get up early to bed, early to rise. Okay, don't waste sunlight. You can get more work done. And so he suggested changing the clocks in the summertime. And no one really thought that was a good idea, and so it didn't happen. And then World War I comes along and said, well, we want people to actually spend more, we want people to get up early and go to bed early, so they're not burning lights and things, after dark as much, save energy. And so they said, we'll just fool them. We'll just tell them it's later than it is. So we'll add an hour to the clock. So daylight time is Central Standard Time plus 1 hour. Okay, so when you go back to school, if you have an 8 a.m. class, bad news. It's not really 8 a.m. because our clocks are set to New Orleans, not to our time. So the 8 a.m. class is really 7:30 in the morning, except it's not really 7:30 because we're calling it an hour later than it is to make you be there on time. Okay, so really it's 6:30 in the morning. We just say it's 8, and then you have an 8 o'clock class. Okay, and so that's daylight saving times. That's basically how it works. Silly idea, but they did that. They do that. When you start daylight saving time and end daylight saving time is a federal issue. Okay, so it used to be that you started first part of April. Last of April and ended in October. And then they changed it so you started 1st of April and ended in October. And then in 2007, they changed it so you end in March, start in March and end in November. Okay. The argument they gave at the time was it saves energy by getting you up early and going to bed late because it did that in World War I, 100 years ago. Unfortunately, technology has changed in the last 100 years. We now have air conditioners and refrigerators and computers and dusk till dawn lights, things that we didn't have back in World War I. And so that means that now it really doesn't save any energy to do this. So this idea doesn't work the way it was intended to work. They also bumped back when we stop it to November because we used it to end in October, and there were people that were complaining, well, that meant kids were trick-or-treating after dark, so they bumped it back into November to stop it so that the kids could trick-or-treat in the light. That also completely failed because the kids just went out an hour later when it was dark because it's no fun to trick-or-treat in the sunlight. Okay, and so anyway, so that's daylight saving time. Another type of time we use in astronomy is universal time. Universal time is outside of the Earth, in a sense, because there's certain things that happen, and it doesn't matter where you are on Earth, it's happening at that moment. You have an eclipse that starts or something, or you have a star that's exploding, a supernova, and it happens, and it doesn't matter where you are on Earth, it's happening. And so what goes on here is that we have this time, we define the time, universal time, to be the local mean time at the prime meridian. So the military uses the same time. They call it Zulu time. Okay, airlines use this time. NASA uses this time. It's called UT, universal time. And so when astronauts are in space, they don't keep track of Eastern time zone or Central time zone or whatever because they're orbiting the entire Earth every hour and a half, going through all these different time zones every couple minutes. And so rather than keeping changing the clock, they just leave it at one time. And that time is universal time. That's 6 hours different from universal time, or 5 hours from, universal time is 6 hours from standard time and 5 hours from daylight time. Remember, Central Standard Time is set for 90 degrees west. 90 degrees is 1/4 of a circle, so that's 6 hours, 1/4 of a day. So if you want to find out what is the time that something's happening for you, Okay, because certain things happen. If you look in the syllabus, I have times the full moon and new moon and so forth. Those times are universal time because those times happen and it doesn't matter where you are on Earth. If you want to know what time it is, in daylight time, that's the summer, take those times and subtract 5 hours. In the winter, when we're in standard time, you subtract 6 hours from universal time in order to find the local time. Now, if you change the different time zones, you would change this thing right here. In fact, if you have a computer or any kind of electronic device, it often asks you to set the time zone, and it sets the time zone accordingly, as universal time plus 5 hours, plus 6 hours, or so forth. And that's how it figures out what time it is. And so that's where this is coming from, is this idea right here. So it's not just astronomers that use universal time.